it says for us, algebraically, switch the x and the y. So for the original point, negative 2 and 3, what's the inverse of negative 2 and 3 going to be? They're negative 2. They're negative 2, great. So I got another volunteer. Tell me the inverse of 1 and 4, please. Thank you. And the inverse of 3 and negative 2? Right, negative 2 and 3. And if you need a note for yourself, is just switch the x and the y's. Good. Okay, you can do this with the graph as well. Here comes my graph. Ready for my graph? Here it comes. I do this on graph paper, I think. Example 2 is going to say f of x is drawn in red. Graph f inverse of x. It's going to be in green for me. If you do yours in different colors, that's okay. If you want to use a little chunk of graph paper, probably wouldn't hurt for this. Okay. I'm only going up to probably 5, like negative 5 to positive 5 is all I'm going to here, so that's all you're going to need. Okay, so here's my beautiful graph. There's 0, 1, 2, 3. Okay, so I took a second while you guys were reading the graph paper out to label all the points and all that stuff on there. Okay, so I did all the labeled all the axes and all that fun stuff. Okay, so what I'm going to do is I'm going to sketch a beautiful parabola here right now. As I do my parabola, you're going to copy down the points on yourself, and then we'll try to, as a class, do f inverse. So I'm going to have a point at 1 and negative 4, 2 and negative 3, 3 and 0, and 4 and 5. And then finally 0 and...
Excuse me, interruption. Mrs. Ladd, would you please down limit 4?
Okay, so if you want those points again on the left, it's going to be negative 2 and 5, negative 1 and 0, 0 and negative 3, 1 and negative 4, 2 and negative 3, 3 and 0, and then 4 and 5. And just for fun, I want to count the dots. So I like to do that. And for double fun, I'm going to state the domain and range of this too. Yeah, I want to state the domain and range too. Can I get a brave soul to tell me what the domain and range is of that parabola, which I'll call f of x? Way to go. Any real number. Very good. So my domain is x can be any real number. Wonderful. Can I have a second volunteer, please? Liam, go. What's the range? Okay, now, if you weren't as brave as Luke and Liam, okay, that's okay. All right? But hopefully you all silently understood where those came from. Okay, hopefully that you did. Okay, so now let's get to the inverse points. I'll give you guys a second to finish scribbling if you haven't done this, if you're not done scribbling yet. Okay, I'll hit pause in the video maybe so I can. I'm going to get a drink of water, and oops, I can say it out loud, and say I'll stay in the classroom and watch you. In order to find the inverse of a function, you have to find the inverse of each individual point. So where do I stop right here? But I can't remember where I was stopping the class. I'll ask for volunteer. Let's see, this first point is negative 2 and 5. What's the inverse of that point, please? Okay, go ahead. 5 and negative 2. So 5 and negative 2 is going to be down here someplace. Okay, so everyone see that? Just the x's and the y's switch. Okay, I have a second volunteer. My second point is negative 1 and 0. What's the inverse of that point, please?
1, 0, negative.
0, negative 1. Next point's going to be 0 and negative 3. What's the inverse of that going to be? So we knew. And 3 and 0, good. Yeah. So all you can see, all we're doing is we're switching the x's and the y's. I had a fourth volunteer. 1 and negative 4, the inverse of that is? Yeah, negative 4 and 1, right? Because like the signs don't switch, you know what I mean? They don't switch positive, negative, just the x and y switches. And then I'll do the rest. We have 2 and negative 3 is negative 3 and 2. And 3 and 0 is going to be 0 and 3. And what is that? 4 and 5 is going to be 5 and 4. That's cool.
Yeah.
I'm going to connect the dots here for a sec, if I could. What did we just make? Oh, goodness, I missed a point there. Is that right? What did we just make, folks? That's the square root function, okay? That's what that is, okay? And we'll show algebraically how we do that in a few minutes here, okay? There's that. Now, can I get someone who hasn't raised their hand today yet to tell me? You're allowed to raise your hand. The domain and range for the inverse. What's the domain of the inverse going to be? Like green graph. That's okay, go ahead.
There is that since there's 2 lines for every.
That's true. You can still do the inverse, though. It's still a function. Though. It's not a function. That's true. But a good point. What he said was all the way along here, this is definitely not going to be a function. And we'll deal with that tomorrow, because that causes major math problems. We can still do domain and range of things that aren't functions, though. What's the domain of that going to be? What's the domain? Yeah, go ahead.
This main is x and then the lines, and then negative 4 is greater than, or less than or equal to x.
Good. So x is greater than or equal to negative 4. XER1. And the only, or negative 4 is what you said. Negative 4 is less than or equal to x. It's the same as x is greater. What's the range going to be? Somebody new, please be brave. What's the range going to be? It's getting wider and wider and wider. Why didn't you say anything? Good. Now, did anyone notice something funny about the domain and range of these two graphs? They're flipped. Why does it make sense they flipped? The graph flipped. The graph is just flipping. The x and the y values are just flipping. Well, they were good. The x and the y graphs are just flipping, so it makes sense in the domain and range, which are your x's and your y's, just flip as well. I didn't want to give this away, but I'm going to today. It's not quite Valentine's Day, but yet this is, I'm going to tell you my Valentine's Day joke. The line of reflection for these two graphs is y equals x. That's the line of reflection. And it makes sense because, again, that's where the x and the y switches. If you flip your page upside down and backwards, it is actually hard.
Why?
Yeah, you don't believe me here.
I see it. I see it.
Okay, good.
I don't.
No, I don't want to flip it. I don't want to flip it because I destroy my whole graph. So I'm not going to.
You do what? How do you see it?
Is that going to work?
No.
Ah! Undo! Undo! I meant to say, ugh. I meant to say, ugh, is what I meant to say. But.
Oh, I see it. I see the heart.
Good.
Oh, there it is.
Okay, it's easier to take your paper. Take your paper. Hard-edge. Go with them.
That's you.
You guys are romantics, then that's fine.
I see it.
Okay, but that's what it should look for a problem. Are we okay with the logic of this? I'll switch up to the y as well. Do a little bit of algebra, and then we're going to probably call it